Hello everyone. So this video I wanted to create a very short video on topological sort. Actually toposort is a very big, I could say not big, but a dense algorithm which it's actually topological sort. Okay, so I wanted to create a separate playlist of topological sort because I could see there are so many questions on topological sort with the different combinations like only topological sort or DP plus topological sort or shortest distance with topological sort. There are a lot many questions on topological sort. So I for sure create a separate playlist out there. So most probably after this basics playlist, I'll move to this topological sort playlist only. But for the basic idea, I just wanted to cover in very short the what is the topological sort because I don't want to cover those basics in the next place, which will be the advanced version of this. And topological sort is the most important topic I could say asked by many of the top MNC companies. They do focus on topological sort a lot. So please pay your attention quietly to this video if you didn't know what is topological set. If you know, I mean, you can just skip it or see it with the 2x speed also. But this is an important topic. That's what I wanted to say. Okay, so now what is topological sort? Now this applies to only the directed graph. Okay, this applies only to the directed graph, and we have to sort the graph. Okay, sort the graph nodes, I could say, in a way that if node I is connected to node j, then node I should come first, then node j. That means you have to maintain the ordering of traversal. You have to maintain the ordering of traversal or the hs going in the directions, I could say. Cool. Okay. So now let's say you have, so of course this will not apply to any cycle uh, graph. Okay. So assume that if you have cycle, let's say this is your cycle 1 to 2, 2 to 3, 3 to 0, 0 to 1. Okay. Now let's say if I start from 0, then 0 should be first, then 1, then 2, then 3. But then 3 is going to 0. So then ideally 3 should come ahead of 0. And this is not possible. So one important observation we could make out of this is if after sorting, if after sorting, we could not find all end nodes, if all n nodes are not available, what does that means? That means it is a cycle. That means it is a cycle. So now your question which we left in previous video, directed graph cycle detection using BFS approach will be done with the toposort. Now toposort is done with the BFS only. Okay, we are doing toposort with the BFS approach only, breadth first search approach. Cool. Now you got this. You can solve it. Okay. We'll go through the code once. Okay. Now our question is, now we got to know what is the toposort. So if let's say this is my graph 1 to 2, 2 to 3, 3 to 4, and 5 to 4, and 5 to 2. No, 5 to 2 I cannot make. 5 to 6 also. Okay. Now, 1 should be before of 2, 2 should be before of 3, 3 should be before of 4. 5 should also be before of 4 and 5 should also be before of 6. So one combination is 1, 2, 3, 5, 4, 6. Or because 3 and 5 both should be ahead of 4. Okay. And all this should be ahead of 4. That's the for sure. 2 and 1 should be before of 3. Okay. Now I can also write this 1, 2, 5, 3, 4, 6 because I only want 1 and 2 before 3. Okay. It could be before 5. It could be before of 3. This is also valid topological sort. So there could be many topological, many unique toposorts available. Okay, so it's not a compulsion that there is only one unique solution. There could be many unique solutions available to the toposorts. Okay, now you could see that for one, it's in degree. Now you know in degree, okay, the edges which are coming to one are called as in degree. The edges which are going out of the one are called as out degrees. So in degree of one is zero. There are no edges coming to one. There is only one edge coming to two. There is only one edge coming to three. Now to 4, there are two edges coming. Okay. And to 5, no one is coming. For 5, it's again 0. So I could start from 5 if I want. I could start from 5, like 5, 1, 2, 3, 4, 6. And this is also valid. Because for 5 also, 5 is coming from no one. Not from 1, not from 2, not from 3, 4, anything. 5 is an independent node in itself. Okay. And then 6 is, okay, again coming from 5. So it's dependent on 5. So 6 should come after 5. So this could also be a valid combination like 5, 6, and then 1, 2, 3, 4. But 4 should come only after 3 and 5 both have come. I hope you got the picture of toposort now. Cool. So what we have seen for in degrees 0, for in degrees 0, that will come first for sure. That will come first. Now, as and when you traverse the, let's say this is your graph, okay? 1, 2, 3, 4, and 5 is connected to 4. So this has n degree. Now I'm writing n degree with a different color. This is n degree of 0. This is n degree 1. This is n degree 1. For 4, it's n degree 2. And for 5, it's n degree 0. Now what we'll do? In our queue, because we are using what? BFS approach, we'll push the nodes initially which has in degree 0. Okay, so what I'll push in my queue, I'll initially push 1 and 5. Now for one's children, I'll go. So there is only one children, 2. And I will decrease the in degree of 2. Because now I have traversed its parent, okay, I can decrease the in degree of 2. Decrease the in degree of child by 1. By 1. Okay, so I'll make the in degree of 2 as I'll decrease this and I'll make it 0 now. Okay, if it's in degree 0, then you can push it to the queue. Then you can push it to the queue. So now we don't need visited array. Why we don't need visited array? Because for all in degree zeros, we are putting it at once. And if it's in degree 0, then only we are putting again another. So that means what I'm doing, if I here I could say 1 and 5 are different components. Okay, 1, 2, 3, 4 is a different component, 5, 4 is different component in itself. This is one component, and this is another component. It's nowhere attached. But I'm pushing both components initial nodes, which has n degree 0, at the very start to my queue itself. So I don't need a visited array. And then I am pushing only if it's in degree 0. If my in degree of any node is becoming 0 while traversing in the queue, then only I am pushing that node in my queue. Otherwise not. So this will in itself will mark it as visited. Okay, so no need of another visited array. I hope you got my point. Okay, and then we are going to the children's and all those stuffs. Okay, cool. So let's have a code and you will get a better idea on how to solve it. Fine. So, okay. Now, this says that there are total of num courses you have to take. So there are total 2 courses you have to take for this example, labeled from 0 to n minus 1. You are given an array prerequisites where prerequisites I is a pair ai comma bi, which indicates that you must take course bi first if you want to take course ai. So if you want to take 1, you have to complete 0. So that means there is an edge from 0 to 1, I could say, right? For 1, I have to take 0. And that means in a graph form, 0 will go to 1. So after I complete 0, I can go to 1. That simply means that. Okay, and it is a directed graph. It's no two ways. Okay. For example, if the pair 0, 1 indicates that to take course 0, you have to first take course 1. Now we have to return the ordering of courses we should take to finish all courses. If there are many valid, return any one of them. And if it is impossible, when it is impossible, when there is a cycle. If it is impossible, we have to return an empty array. Okay, fine. So let's have our answer array, vector of int answer array. And I'll also make an adjacency list. So what we'll do for int I0, I less than prerequisites dot size. Now what we will push, we'll push I I1 on I0. Okay, this should be of num courses. Okay, now this should be I from I1 we have to push I0. So adjacency of prerequisites of I1 dot push back prerequisites I0. Cool. Now we are done with our adjacency list. Okay. Now we have a queue, of course. Q dot. Okay. Now we need to first maintain in degree. So this is what we are doing. We will have one in degree array also. Okay. Which is in degree of num courses and 0 initially. Okay. Now I1 is putting a link to I0. That means to I0 our in degree is increasing. So what we'll do is in degree of uh, in degree of prerequisites I0 will be plus plus. Good. Now we have Q. What we will do? Whatever's in degree is 0 until the num courses will go. If in degree of I is 0, then we will push it to our Q. What? That node. This is I. Okay. Now, while not Q dot empty, we have a node which is Q dot front, Q dot pop, and we will go to the adjacency. So for auto ampersand element in adjacency of node, okay, what we will do first, we'll decrease its in degree. So we'll decrease the in degree of element minus minus. And now after decreasing, if it has become 0, then only we will push it to our Q. So Q dot push element. And once we are popping this nodes, we will push it to our answer also. Okay, so that means our sorted order. So answer dot push back this node. And if it's 0, we are pushing it to our element. Fine. Now, if your this answer dot size is equal to your total courses, that means you are correct. Then you will return answer array. Else you will return what? Empty array. Okay. Same way if you're checking for the cycle. So if your answer dot size is num course, that means there is no cycle. If it is less than num courses, that means you have detected a cycle for sure. Okay. Let's check this. So we are done with the topological sort basic question. I'll put some 2 3 links for your practice, and this is also called as Kahn's algorithm. It is also called as KAHN, Kahn's algorithm. In some of the places you might find this word. Okay, so we are done with the topological sort. In the next video, I'll move to the shortest distance algorithms. Okay, for indirected, directed, and maybe I can complete the playlist in the next 2 3 videos. Then we'll move to the topological sort. Share it with your friends.